Let's look at some more examples for substitution method. If an integral is of the form f prime of x by square root of f of x dx, we do the substitution u is equal to 2 times square root of f of x. Now, we could always use u is equal to f of x and do it. But doing this way simplifies the problem to a large extent. So u is equal to 2 times square root of f of x is equal to 2 times f to the power of 1 by 2 of x. So another way of writing square root. Now differentiating this, du is equal to 2 times 1 by 2 times f to the power of 1 by 2 minus 1 of x times f prime of x dx. 2 cancels out. This becomes minus half. So we have f of x to the power of minus 1 by 2 times f prime of x dx. Now, since it is a negative exponent, we take it down. We get f prime of x dx by f to the power of 1 by 2 of x, which is nothing but f prime of x dx divided by square root of f of x. We have ended up with the entire thing that is under the integral. So when we do the substitution, what happens? We are left with integral of du. Pretty straightforward. So integral of du is equal to u plus c. And substituting back, we get integral of f prime of x dx by square root of f of x d is equal to 2 times the square root of f of x plus c. Substituting this makes it very, very simple. Okay, let's look at the next one. If an integral involves expressions of the form square root of 1 plus x square or 1 by 1 plus x square or something similar, we use u is equal to tan theta. Now, why would we do that? Because 1 plus tan square theta is equal to sec square theta. So instead of having two terms here, we will end up with a single term. And here, the square root will disappear. 1 plus tan square theta will become sec square theta, and square root will cancel. Okay, so let's do the simplest version of that. So integral of dx by x square plus 1. So let x equal to tan theta. Dx is equal to sec square theta d theta. So substitution, when we carry out, we get integral of dx by x square plus 1 is equal to integral of sec square theta d theta divided by tan square theta plus 1, which is equal to integral of sec square theta d theta divided by sec square theta. Sec square theta cancels out. We are left with integral of d theta, which is equal to theta plus c. And finally, x is equal to tan theta means theta is equal to arctan of x. So which means integral of dx by x square plus 1 is equal to arctan of x plus c. Let's look at integral of square root of a square minus x square dx. So let x equal to a sine theta. So now we are substituting x with a times sine theta. So theta is equal to arc sine of x by a. Square root of a square minus x square is equal to square root of, after substitution, a square minus a square times sine square theta. A square is common. We take it out of the root. So we end up with a times square root of 1 minus sine square theta. So which becomes a times square root of cos square theta, which is equal to a cos theta. Differentiating this, we get dx is equal to a times cos theta d theta. integral square root of a square minus x square dx is equal to, after substitution, square root of a square minus x square is a cos theta. Dx is a cos theta, d theta. So we have ended up with integral of a square cos square theta d theta. Simplifying that, we get a square times integral of 1 plus cos 2 theta by 2. So we are using a trigonometric identity. So we have divided by 2, we take it out because it's a constant. So a square by 2 times integral of 1 plus cos 2 theta d theta. We know the integral of 1, we know the integral of cos 2 theta. So integral square root of a square minus x square dx is equal to a square by 2 times integral of 1 is theta, and integral of cos 2 theta is sine 2 theta by 2 plus c. Opening up the bracket, we get a square by 2 theta plus a square by 4 times 2 sine theta cos theta, because sine 2 theta is 2 sine theta cos theta plus c. Let's simplify this. We get a square by 2 times arc sine x by a. Theta is equal to, where is that? Theta is equal to arc sine x by a plus, simplifying this, a square, a and a cancel out. So we have x by 2 times square root of a square minus x square plus c. Finally, we have integral of square root of a square minus x square dx is equal to x by 2 times square root of a square minus x square plus a square by 2 times arc sine x by a plus c. So that is some additional substitutions that we have looked at. Now, here, instead of substituting x equal to a times sine theta, we could have done a times cos theta as well. So whatever we arrive at, we may arrive at r cos x by a, but the difference between them would be a constant. So we can convert one to the other, take out the constant and add it up with c. That was substitution. There is one more substantial one which we will look at in the next session. Again, let me remind you, there is a link to a PDF book which describes all these in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now. Bye.